Hello class, welcome to our second lesson dealing with polar graphs and their equations. First thing that we want to talk about is just a review of what we discussed on the previous day's lesson. Remember, rectangular coordinates are x comma y. Polar coordinates are always r theta. I don't know if I mentioned this or not, but just a reminder, some theta questions will be in radians, some will be in degrees. Obviously, you may need to convert from one to the other from time to time. The question will tell you what you want to look at often. But there's some freedom sometimes in how you write your answer, but just something to think about as you're looking at those scenarios. And then your conversions are still used. X equals r cosine theta, y equals r sine theta. Pythagorean theorem, r squared equals x squared plus y squared. And tangent theta is opposite over adjacent, which is y over x. Those are the things that we'll be using again today. Okay, again, there's a lot of info here. Plotting the pair of polar coordinates. Let's talk a little bit about negatives here. So I would probably deal with the angle first. Notice this says negative 45. So negative 45 would start at 0, but instead of going up 45, it goes down 45 to 315. Now the radius should be 3. That would be 3 out towards it, but it goes the opposite way. So you have to go the opposite way towards 135. And so that's why the answer ends up in quadrant 2. Two other points that are the same as that. Negative 3, 315. If you just add 360 to the number, we know it's in that same spot. So just adding 360 or 2 pi to the angle would be in the same location. Or we could say it's 3 for the radius and 135 going out in the direction to the second quadrant, because that's a 180 difference from the other angle. In terms of the rectangular coordinates, you're just going to plug into r cosine theta and r sine theta. And remember, you want radical numbers with root 2's involved. And so this would be negative 3 root 2 over 2 and positive 3 root 2 over 2. And remember, that's going backwards in the x direction and up in the y direction. So it should have a negative x and a positive y. That makes sense with those situations. The next one is a rectangular coordinate. So you want to pay attention to the directions to make sure, was I given a rectangular coordinate? Was I given a polar coordinate? So this is x, y. So think of this. You can draw the coordinate plane here, x and y. It's on here. Okay, this one's actually easy to draw because it'd be 0 and then up 1, 2, 3, 4. And really, you don't have to do a whole lot in terms of its polar coordinates other than saying, well, its radius is 4 and it's 90 degrees or pi over 2. And then if you add or subtract 360, that will give you the same angle, same point, 4 comma 450. And then if you go the other direction, 270, it would be negative 4 because you want to, instead of go down to 270, you want to go the opposite direction, okay, up to 90 again. So this question, if it ends up on the axis, is actually pretty easy to find, and there's not a whole lot of work that has to be done compared to, say, the last question. The next question deals with x and y values that are both negative, and so it may be hard to draw it originally, but it should end up in quadrant 3 because the x value is negative and the y value is negative. To figure out what r and theta are, you want to use the second group of formulas. So x squared plus y squared equals r squared. So just do Pythagorean theorem. You'll get 3/4 and a fourth. R squared equals 1, so square root that, and you should get r is 1. So notice that my answer for q is on that first ring because r is 1. It's important to remember that when you do the tangent theta piece, that the answer you get for theta may just be the reference angle. So if you simplify y over r, it becomes 1 over root 3. If that's the case, tangent inverse of that, if you plug it into a calculator, it should just be 30 degrees. But you have to recognize that that's actually in quadrant 3, so it should be 180 plus the 30 degrees. That's the difference in that scenario. So the angle should be 1 comma 210. I could add 360 to that or subtract 360, and that would be the same angle. That's where the 570 comes from. Or if I do a negative one for the angle, I just need to know what it would be in the other direction, and that would be 30 degrees. And then it'd be 30 degrees with a negative one, which would put it back towards the 210 number. So when you're dealing with rectangular to polar, use the Pythagorean theorem, tangent with the reference angle, and to work backwards to be able to figure out what theta really is. Okay, a few conversions between polar and rectangular. You just use your 4 conversions still. So x squared plus y squared equals 9 is a circle with radius 3. But in polar format, x squared plus y squared equals r squared, and you square root it and you get 3. Now technically it's plus or minus 3, but that's irrelevant because it just goes in the same direction, or just goes the other direction, but it's the same circle. So if you see x squared plus y squared, you can make it r squared right away, or vice versa if you're trying to get back to rectangular. Next question is a line, so I could solve for y if I wanted, and it would be a line. Notice it's really easy to graph that in rectangular because a line is easy to graph in rectangular coordinates. A little bit more challenging in polar coordinates. The goal is to take x and make it r cosine theta, take y and make it r sine theta, and then typically in these questions you want to get r by itself. So you could factor out the r. So what's happening here is I'm taking the r out of both of these, I'm factoring it out front, and that leaves me with cosine theta plus sine theta, and I'm going to take that and divide it over to the other side. So I have 3 over this whole thing of cosine theta plus sine theta. The giveaway once you get further into polar coordinates is if you see a number divided by something with sine plus cosine, it was probably a line originally, and this is the reason why. The next 2 questions have r equals 4 and then a trig function. If it's not sine or cosine, change it into sine and cosine by making it division. And so secant is the same as 1 over cosine, so I just put cosine on the bottom. Now notice this is a polar coordinate to start with, and I want to make it rectangular. So now it's 4 over cosine. I take cosine and multiply it to the other side. So 4 equals r cosine theta. And r cosine theta is the same as x. And that would just be a vertical line up at 4. Notice how much easier it is in rectangular format to draw that versus polar, because it's something that deals with a line. The next one is exactly the same except it's sine theta, so it's 3 over sine theta. I multiply that to the other side, so r sine theta equals 3. And r sine theta is the same as y, so y equals 3, and that would be a horizontal line up at 3. The focus of your homework is mainly on plotting the other points and figuring out the rectangular versus polar coordinates. Those last couple questions are good to look at to make sure you understand some easy relationships between the 2 conversions of polar to rectangular. Have a good day, everyone.